Hi everyone, my name is Anisa Jazrabani and I'm a PhD student at McMaster University. Today I'll be giving you a rundown of my research summary, which is basically how the facies architecture of the Upper Cretaceous Dunvegan Formation shapes our understanding of its hydrogeological implications in the region. So, just a quick background in terms of where we're located geographically. My study site is basically Fort Liard, so particularly the Liard Basin in the Western Canada Sedimentary Basin. So a lot of extensive work has been done on the Dunvegan Formation, particularly in the Peace River region, as well as in northern Alberta. So my study now aims to understand the Dunvegan in the Liard Basin. And eventually, the goal is to combine all three of these our understanding of the Dunvegan in all three of these areas to create an amalgamated understanding of how the Dunvegan basically like how the Dunvegan varies both spatially and how it evolves over this particular geographic area. So just to summarize, the Liard Basin is located in the northwest corner of the Western Canada Sedimentary Basin. My work in particular is in Fort Liard, so it's the town of Fort Liard. The Dunvegan Formation underlies Fort Liard in the Northwest Territories, and in that particular region, it's a really important resource of fresh water for the development of First Nation communities, particularly Akkodane Co. So if you pay attention to the first model here, that was the model that was created by Stott in 1982. And he deduced the formation to be sandstone and conglomerate dominated. And he was able to do this through regional mapping of the area. In 2020, Nathan Glass from the University of Guelph was able to refine Stott's initial model. He collected core logs, and he was able to do an extensive study. And this final model is basically a refined version of what Stott initially thought the Dunvegan Formation to look like. And as you can see, there's a stark difference between what we initially thought and our understanding of it presently. So the Dunvegan Formation was initially interpreted as post-grained alluvial fans. And you have to keep this in mind because this was our initial assumption. So this is my study site. And as I mentioned previously, I'm working close to the town of Fort Liard. And this, what you see in blue is basically the Petittot River. And the transect expands about 40 kilometers in terms of distance. This is the main highway. So the highway actually transects the river right here. So there's a bridge that goes, that cross-cuts it. And the best way to map this river is to actually canoe it all the way. So this is upstream right here. And the best way is to basically canoe it all the way downstream. Or if you start from the town of Fort Liard, you can hike up the river and collect your measured sections, do a bunch of field work. And that's what we were able to do. We were able to do both last summer. We have a couple of measured sections from up here, and we also have photo mosaics of the Dunvegan Formation. So about 500 or so photographs that were used to that were basically used for our preliminary study. So what are our project objectives? Currently, I'm going to highlight the four main ones. It's to build a detailed sequence stratigraphic model using your measured sections. These were already done this summer. We need to validate our model using seismic, resistivity, and well data, and this is planned for this summer. We need to then create a hydrogeological and sequence stratigraphic model. This is basically an informed groundwater flow model. And what this would do would essentially be to incorporate our hydrogeological parameters to assess your groundwater quality. So as I mentioned previously, the Dunvegan Formation is the main aquifer in the region, and it's particularly very important for the hamlet of Fort Liard because they rely on this particular groundwater resource as their main source of water. And there's a lot of drilling and fracking activity nearby. And our postulation is that the Dunvegan is contaminated. So in order to determine that, we first need to understand what the Dunvegan looks like in our particular study site. And then once we have a clear understanding of what the formation is, how the sequence stratigraphy of the region is, how the aquifer and the aquitard are arranged, we would then be able to figure out pinpoint the source of contamination and thereby come up with ways to mitigate it in the future. So our methodology basically surrounds field, like it's centralized around fieldwork. So the first one is surface geological mapping, and we would achieve these using measured sections from outcrop studies and photography. And we were able to do both of these last summer. This summer, we would be doing high resolution drone photography in the Petitot River. A drilling event is also scheduled for 2023 in May, and that would help us with getting core logging, downhole geophysics, and hydrophysics. And finally, we would juxtapose all of this information with a regional airborne electromagnetic and local surface geophysics. So you're also getting an electromagnetic survey that would be juxtaposed on top of your all of the other models. So you have all these different layers and you have all of these different ways of understanding the Dunvegan. And basically my project brings about all of these subdisciplines together to create a more comprehensive understanding of this formation. So here's an example of the lower Dunvegan in the outcrop. And this is our first meandering channel. So this is a really nice fluvial unit, and you can see fine grain channels cross-cutting into the sandstone, and they're overlain by a floodplain. So fine-grained fluvial, and this is basically fine-grained fluvial with mudstones above. And this is what Nathan Glass determined as the lower Dunvegan in the field. And although in his lower Dunvegan unit, Stott didn't include a marine unit, there seems to be a marine Dunvegan here above the upper Sully. These are the measured section. This is essentially a bedding diagram that would come out of photographs that we've taken in the field. So this is one way to utilize the data that we collected. So our current work in progress is to extract grain size and any key stratigraphic features from these photographs, and to also approximate the scale of the cliffs and the stratigraphic units from our high-resolution drone photographs that we'll be getting this summer. We would then be able to stitch all of these photomosaics together to obtain laterally continuous and extensive sections, which would then be used in our sequence stratigraphic models as well as our fluid flow models. Later on, we would do a high-resolution core logging exercise, and that's scheduled for this summer. That will go hand in hand with the drilling. And this would help us determine the different facies that are present, and we would then be able to determine the relationships of these facies with one another. So our study will be complemented by measured sections in the field, as well as thin sections and core plugs. And then once we have all of this information together, we can segregate our sections into facies units as well as systems tracks. And that would basically help determine, and we would be able to come up with a sequence stratigraphic model based on this. So thank you so much for listening. This is basically a work in progress at the moment, and these are my preliminary results. This is where we are in terms of the current progress of my research. And as we could get more and more data, our understanding of the Dunvegan gets more and more refined, and we're able to either verify what is already known about the Dunvegan, or basically contradict what we know about the Dunvegan. And one of our key findings is that we don't think there are alluvial fans present in the region. And our photographs actually revealed that. So as we dive more and more into understanding this formation, our understanding gets better. And it also has a lot of hydrogeological implications because it directly affects the people in the town of Fort Liard. Thank you so much for listening. And if you have any questions, please feel free to email me. This is my email address. And thank you very much.